June 24th, Google DeepMind did something that might just change how robots work forever. Carolina Parada and her team unveiled Gemini Robotics on device. A stripped-down, supercharged version of Gemini 2.0 that does not need the cloud, Wi-Fi, or even a whisper of internet to function. This thing runs directly on the robot, which means no delays, no outages, and no waiting on a server halfway across the planet to figure out what to do next. Just real-time thinking in action, right there on the factory floor, in your home, or even in deep space. It is like cutting the leash and handing robots their own brain. One that is fast, adaptable, and always ready. Now, because this model runs offline, efficiency is everything. DeepMind's engineers shaved the architecture until it is compact enough for the dual-arm Aloha rigs they train on. Yet it still handles vision transformers, language encoders, and action decoders in one neat package. We are talking inference that fits on the kind of embedded GPU boards you would stick inside a mobile manipulator, not a server rack. The result is that the robot's control loop stays well under traditional latency thresholds, tens of milliseconds instead of hundreds. So when a sensor pings a sudden shift in an object's pose, the planner can react before momentum carries the object somewhere you really did not want it to go. Performance numbers back that up. DeepMind published side-by-side charts that pit on-device against the very same flagship hybrid and against what used to be the best purely local VLA. On-device practically glues itself to the hybrid curve across visual, semantic, and behavioral generalization tests, and it pushes well past the previous on-device champ, especially when you throw unseen objects or odd lighting at it. In instruction-following benchmarks, multi-step tasks with a lot of natural language nuance, it closes most of the gap too. That is wild because the hybrid model still has a direct fiber line to those hulking TPU pods, and yet the little sibling hanging out on an edge box is almost keeping pace. Alright, real tasks out of the box. The demo reel shows the robot unzipping soft lunch boxes, folding shirts with actual creases, pouring salad dressing into a narrow container without splashing, and even sliding a card out of a deck. Tiny, fiddly stuff that usually takes forever to hand program. It does all of that after seeing maybe 50 to 100 examples. That session count matters. Data collection is expensive whether you are in a simulation like Mujoko or on real hardware with a human operator showing the motions. Cutting the fine-tuning set down to double digits slashes the barrier for researchers who do not have thousands of hours of teleop footage lying around. Alright, now remember when self-driving cars felt like sci-fi back in 2019? Now over 400,000 Teslas drive themselves every single day. And while no one was paying attention, AI adoption exploded by 270% in just 3 years. Companies once skeptical are now 15% more productive than their competitors. McKinsey predicts AI will add $13 trillion to the global economy by 2030, but also force 375 million people to switch careers. And those roles will demand serious AI skills. That is why I am inviting you to an exclusive free 2-day live AI training by Outskill, normally priced at $895, now completely free for my audience. This is not a boring lecture. It is 16 hours of immersive, hands-on learning, spread across Friday from 10 o'clock in the morning to 1 o'clock in the afternoon Eastern Standard Time and Saturday and Sunday from 10 o'clock in the morning to 7 o'clock in the evening Eastern Standard Time. You will learn prompt engineering, master over 20 powerful AI tools, automate your workflow, analyze data without code, use AI in Excel and PowerPoint, generate videos and images with AI, build tools without writing a single line of code, and even create your own AI agents. It is built for professionals in tech, business, marketing, HR, sales, and more. People from over 40 countries have already joined, and if you are serious about growing with AI, you definitely should too. So click the link in the description to grab your free seat now. Do not forget to join their WhatsApp community for updates. The intro session starts Friday at 10 in the morning Eastern Standard Time. Be there. Alright, now back to Google. Speaking of demos, Google only trained on device on its internal Aloha platform, but then they ported the exact same weights to a Franka FR3 BRM workstation and to Apptronic's Apollo humanoid. No retraining from scratch, just a short adaptation pass, and the model suddenly knew the different joint kinematics. On the Franka, they ran sequences like belt drive assembly, lining up pulleys and tensioning a belt, plus folding a long summer dress without stretching the fabric. On the Apollo humanoid, which is much taller with totally different limb proportions, the model still obeyed spoken instructions, manipulated random household items it had never seen, and stashed a Rubik's Cube into a pouch like it had been practicing that party trick all week. The takeaway is that we are inching toward embodiment-agnostic skill libraries. Train once, transplant almost anywhere. Developers who want to poke at the guts can sign up for the Gemini Robotics SDK, which ships with interface code for live robots plus full MuJoCo simulation scenes. MuJoCo's physics is fast enough to generate contact-rich demonstrations on a laptop, so you can gather those 50 demo datasets in virtual kitchens or mini-factories before ever touching the physical robot. Then you fine-tune locally, because yes, this is Google's first VLA where fine-tuning is officially supported, and push the updated weight straight onto your bot's flash storage. Early access is through a trusted tester program. They are not opening the floodgates just yet, partly because of safety reviews. On that front, DeepMind keeps echoing its AI principles. Be helpful, do not be reckless, all that good stuff. The company wires semantic filters into the live API stack to watch for awkward or unsafe instructions, like someone casually telling the robot to hand them a knife blade first. Under the hood, a low-level safety controller cross-checks torque limits, collision cones, and velocity caps. There is also a new semantic safety benchmark that tries to brute force the weird corner cases, think ambiguous phrasing or conflicting tasks, to see if the system holds up. The Responsible Development and Innovation team runs impact analyses, then the Responsibility and Safety Council signs off before any code leaves the lab. Robots are heavy, and the message here is that you really want multiple layers watching your back when the arm is swinging near a human coworker. A quick note about architecture. The flagship hybrid is still more capable overall. You toss it a completely novel multimodal riddle like, pick up the transparent cup with the blue marbles and rotate it until the marbles form a diagonal line, and the cloud-boosted reasoning stack will outperform the purely local model. But Parada herself told The Verge that everyone was surprised by how strong on-device is. She called it a starter model, yet it already edges toward production grade when connectivity is shaky or data sovereignty rules forbid cloud calls. Think rugged warehouse aisles where Wi-Fi dies behind rows of steel racks, or defense contractors who keep everything on-prem for obvious reasons. Zooming out, this release is a nudge toward robots acting in real time on factory floors, fulfillment centers, or offshore rigs where cables are a luxury. If you have got a pick-and-place task that occasionally shifts when pallets arrive late, an adaptive, low-latency controller that learns new packaging SKUs in one afternoon could shave serious downtime. It also chips away at the cost of ownership. No recurring cloud compute bill, fewer security audits for data egress, and the possibility of reflashing the same model across different mechanical platforms you already operate. For those who worry about compute ceilings, Gemini Robotics on device is engineered to squeeze into bi-arm rigs right now, but it could scale down further as embedded hardware evolves, NVIDIA's Orin modules, Qualcomm's AI-accelerated SoCs, or even custom ASICs could host future iterations. Meanwhile, the SDK's fine-tune knob means you do not have to wait for DeepMind to push a global update just so your cupcake frosting bot learns a spiral pattern unique to your bakery. You record the task a couple dozen times, run the optimizer locally, and the model folds that new motion primitive into its policy. One more angle, because everything sits on the robot, latency advantages extend beyond motion planning to perception feedback loops. When the manipulator is threading a cable through a tight harness, every extra millisecond of vision processing is 1 millimeter of overshoot. Cutting that round trip to the cloud buys you precision you can literally measure with a caliper. That is the difference between a production-grade harness assembly cell and a flashy research demo that still needs a technician nudging the cable every so often. Developers get documentation that walks through connecting the live API safety layer, deploying on Debian-based images, and using the MuJoCo plugin to mirror real-world joint limits. There is even a quick script to convert demonstrations recorded in Icing or RoboSuite into the expected proto format. The trusted tester group will send feedback, which feeds into continuous safety audits. That is why access is staged, not open source. They want eyes on real deployments before an enthusiastic hobbyist straps a chainsaw to a mobile base and live streams the result. To wrap all this into practical impact, think of logistics hubs juggling SKU changes every week, hospitals needing a sterile, self-contained aid that cannot rely on hospital Wi-Fi, or even planetary rovers trundling across lunar regolith where a satellite ping takes far too long. On-device could become the embedded brain for each of those scenarios. And because it inherits Gemini's multimodal reasoning, it will not just execute waypoints. It can read labels, interpret gestures, and respond to someone saying, "No, grab the smaller valve." That conversational agility bridges the gap between rigid industrial arms and something that feels like a coworker, with motors. Alright, that is the rundown on Gemini Robotics on device. Offline brains, quick adaptation, strong safety scaffolding, and a clear path for developers via the new SDK. If you are in the robotics space, sign up for the Trusted Tester queue and start queuing those demonstrations. Catch you in the next one.